typically, during compression, you know, you choose a preset, and you just say, that sounds good. It says for medium speed delivery, choose this preset. Let's go for it, right? So let's talk a little bit about what's going on behind the scenes here, because it's really cool. It's just really complex. So compression is a couple of different things. First, it's the analysis of the pixels within the frame. I find it helpful to, when I'm compressing, to stop thinking of that picture that I see as a picture with a person in it and a sky and grass, and just think of it as 720 pixels times 480 pixels, whatever number that would be. Because that's how the computer sees it. It just sees a whole bunch of pixels. And right now, at this moment, that pixel is 50% blue. The next moment, it drops down to 40% blue. And that's happening 720 by 480 times 30 times every second, or whatever frame rate you're giving it. So, so you're asking the computer basically to analyze every single pixel and kind of look at the luminance and the gamma changes, so the brightness or the darkness of the pixel, and then the value of the color within that pixel. Okay, so we'll get back to that in a minute. So then there's different kinds of frames, because within a second, obviously, you have to see so many different frames at a time, right? So there are three different kinds of frames. There's I frames, there's B frames, and there's P frames. Sometimes you'll see this referred to as keyframes, which are not keyframes like you think of in animation. These are I frames, P frames, and B frames. It's also called the GOP structure, or the GOP size, and I'll get into that in a minute too. And then, of course, there's the bit rate. And bit rate is typically measured in kilobytes per second. You'll see it measured in megabytes per second. Just drop the zeros. And as the more high definition discs come out, you're going to see more megabit per second bit rates. And then you've got different kinds of bit rate. You've got a constant bit rate, you've got the variable bit rate, and I'm going to explain that in a minute. And then you've got the frames per second, which is not really frames per second. Like if you're a film or a video maker, you probably know what you're shooting in, like 24p or 2997 or 60i. These are all illusions. Video doesn't know what a frame is. It's what we say the video frame is. We're just telling the computer how many times to count during 1 second, how many times it should take a sample of all these I frames and P frames and B frames per second. So I think I break that down in more plain language. Yeah, I do, good. Okay, so the I-frame thing, the GOP structure, this is really important because this is how nice your frames look each second. So an I-frame is a huge, really beautiful picture. It's compressed, but it gives it optimal bit rate. It says, you know what, for this set of pixels, I'm just gonna send as much information as I can to this person's web browser, or to their media player, or from their DVD player to their television. It's going to be it's going to look really sharp, really nice. People are going to love this. That's great, but the problem is that that's a big file, obviously, because that's the optimal bit rate. Lots of bits are being eaten up when they're sending us an I-frame. So then there would be like a P frame. So if this is like a sequence of still images within motion picture, right? This is a film strip, let's say. So we would start out with an I-frame because it looks really nice, and it'll take a sample of that set, right? And then it uses this frame, the first one, and the third one when it's analyzing. Before it does the compressing, it's analyzing all this, and it says, okay, so this person here changes only so much between these two frames. So I'm going to kind of like split the difference, and this sky doesn't really change a whole lot at all, so I'm just going to kind of skimp on the sky. I'll just kind of reuse a lot of the pixels from over here. You know, so it's like taking samples of how much it changes and kind of judges whether it needs to really give it a whole lot of attention or if it can kind of fake it. So P frames are not as good as iframes, but they require less bits. But they're pretty nice because they look they compare themselves with the previous and the next frame coming up. And then there's B frames. So if we were doing a GOP structure with, let's say, 1 iframe per second and I don't know, 15 P frames and whatever the rest would be B frames, kind of scattered out between all that stuff, we would have a fairly nice compression. But B frames, you know, they're kind of like, they're the worst quality. So, I mean, I don't know if you can really tell from that distance, but I tried to make this one look like it was less quality. You know, it's not that great, but it's a lightweight frame, and especially for sequences like this, where, you know, the person's really small in the frame, they're not moving that much, you know, big deal. I mean, let's fake it for a couple of frames per second. No one's going to notice. We've got so much great stuff going on anyway, but we're saving on our bits. So the number of iframes to P frames to B frames, that's the GOP size, or the GOP structure. So if you say, you know what, I'm not so worried about bandwidth, I've been given lots of bandwidth, and no one's coming to my website anyway, so I'll give them a big file to download, just make them wait for it. You might give it like, I don't know, 5 iframes, a couple of P frames, not too many B frames. And that's typically, I mean, it varies between codecs, what kind of frames it uses. They all have different specs. It's easiest to remember that you're not going to have the option if that codec doesn't use the B frames or something like that. But when you see things about GOP structure, or when you see things about keyframes, that's what it's referring to. So that would mean that the more keyframes you have per second, the nicer the file would look, but the bigger the file would be, right? The fewer keyframes you have, i.e. the fewer iframes you've got, the smaller it's going to be, but it's not going to look so great. Yeah, so, and then there's the actual bitrate itself. So bitrate basically is just determining how many bits per frame, and then you times that, you know, over the whole span of the video that you're sending out. And it's, the higher your bit rate, the bigger your file, right? It's pretty simple. Go lower on your bit rate, and the smaller your file will be. But, of course, the lower the quality of that file. So, it's a balancing act that you're going to have to just kind of experiment with. And that's the thing about compression. It's not necessarily rocket science, but it is prone to disaster, like rocket science.